Okay, ladies and gentlemen, welcome to the third and final video for section 2-3 in your textbook. This one will cover conditional families or related conditionals. Remember that we have our original statement, our original conditional, known as the parent conditional, in the form P implies Q, or if P, then Q. Okay, so that's what we're talking about. We're talking about taking a conditional statement in the form if P then Q and coming up with the related conditional statements to that. Now, all three of these words on this page are considered vocabulary words for this course. So converse, inverse, and contrapositive are all vocabulary words. The converse is the most important related conditional to our original statement. Our original statement is P implies Q. The converse is Q implies P. In other words, it is a conditional formed by switching the hypothesis and conclusion of an existing parent conditional. In other words, it is the statement if Q, then P. So we're simply switching the hypothesis and conclusion of the original parent conditional. The second related conditional, named the inverse, is similar, but instead of switching, we negate. We take the statement not P implies not Q. It is a conditional statement formed by negating the hypothesis and conclusion of an existing parent conditional. So it's the statement if not P, then not Q. The third and final related conditional, we are actually going to do both. We are going to negate and switch, giving us the statement not Q implies not P. So we're both negating and switching the hypothesis and conclusion of an existing parent conditional. In other words, we're saying if not Q, then not P. So we're going to do a couple examples of this, and in the process we'll also discuss truth value of these related conditionals. Again, but the truth value thing is just going to be more practice of us judging whether or not a conditional statement is true. It's not going to be a new skill. Again, remember that the only way to show that a conditional statement is false is to show that the hypothesis is true, but the conclusion is false, by providing a counterexample where P is true, Q is false. Okay, so let's look at an example here. Here are some rather convoluted directions. Write the converse, inverse, and contrapositive of the conditional statement. Determine if each related conditional is true or false, and if it's false, give a counterexample. So we have three things we need to do here. Write out the converse, inverse, and contrapositive in words and symbols. Then we are going to judge the truth value of each of these three statements, the converse, the inverse, and the contrapositive. And then finally, any that we declare false, we have to provide a counterexample. So again, this is our initials. Our first statement here is our statement P implies Q. That's our parent conditional, which means that our hypothesis is the measure of angle A is 35 degrees, and our conclusion is angle A is an acute angle. It is worth noting that this particular equation is a conditional statement is a true statement. So when we write out the converse, remember that the converse is if Q, then P. So when we write this out, all we're doing is switching the blue and pink portions. So we would say if angle A is an acute angle, then the measure of angle A has to be 35 degrees. And I say has to be 35 degrees because that's what equal means. So we have to think about this very carefully here, because this conditional statement, when we switch the hypothesis and conclusion and we write out the converse, we actually create a false statement. This is not a true statement. This is false. And here's your counterexample. Remember that the counterexample would have to mean that the hypothesis part of the statement is true. So here we would have to come up with an angle measure for A that would cause A to be an acute angle that is not 35 degrees. So to provide a counterexample, we could simply say the measure of angle A could be, and then come up with some other number that is not 35 degrees, but is still an acute angle. That would be a counterexample to the converse and would guarantee that it is false. On to the inverse. Remember that the inverse is the statement, if not P, then not Q. So we go back to the original parent conditional, and we are going to negate the hypothesis and conclusion. So instead of saying if the measure of angle A is equal or 35 degrees, we would negate that by saying the measure of angle A does not equal 35 degrees. Then we need to negate the pink part as well. We would say angle A is not an acute angle. So again, then we need to consider the truth values. We need to think to ourselves, is there any number we can come up with, any measurement for angle A that we can come up with that is not 35 degrees, but would still result in A being an acute angle? And if we can, then this is a false statement. So hopefully you're going, yeah, it's the exact same argument as the last one. This is also a false statement, because the measure of angle A could be any other acute angle measure other than 35 degrees. Say we went with 31 degrees this time, because it doesn't matter what number we give as long as it's not 35 degrees. Sorry, my pen is acting up here. There we go. That would be a valid counterexample for that conditional statement. On to the contrapositive. This is the last one for this one, and I actually think I'm going to cut off the video there, and eventually I'll do a fourth video with the other example, because really this shouldn't take 2 examples to do. If not Q, then not P. So what we're going to do is we're not only going to negate, but we're also going to switch the hypothesis and conclusion of the original statement. Now please notice that this means that the contrapositive is the converse of the inverse. We can just take the inverse and switch its hypothesis and conclusion. So we need to say if angle A is not an acute angle, which is the negation of the original conclusion, then the measure of angle A does not equal 35 degrees. Now, interestingly, even though we've come up with counterexamples for both the converse and the inverse, our contrapositive here is a very true statement, because the only way we could come up with a counterexample to this would be if the conclusion of this statement was false. And the only value for which the conclusion is false is if angle A is 35 degrees. And if A is 35 degrees, then that would make the hypothesis portion of this statement false, because 35 degree angles are acute angles. So here where it says if angle A is not an acute angle, that means it is not possible for A to be 35 degrees, which makes this a true statement. Thank you very much for your time. I will eventually record the other example and throw it up as an additional example video, but not today. Thank you for your time.